Today we are going to learn how to classify images using transfer learning. We will use the MobileNet architecture and learn how to classify fish. For example, this fish is a sea bass. In order to do that, we will take a big dataset for thousands of images divided to 9 different classes of fish, and we will train this model using the transfer learning technique. And after that, we will use this pre-trained model in order to classify a new and fresh image. So let's start. We will create a conda environment based on Python 3.9.16. I'm using TensorFlow 2.10, and we will also use NumPy and OpenCV. The first Python file deals with preparing the data. So we will take the dataset and divide it to train and validate folders. 85% will be train images and the rest will be the validation images. As you can see, we have 9 folders. In each of the folders there are thousands of images. For example, this is a shrimps images. So the purpose of the first Python file, Python code, will be generating 2 folders of train and validate images, and inside those folders we will create our classes folders, and in each of those classes we will create a random copy of the images. So this is the purpose of the first Python program. The next step would be creating a new Python list, and we would like to run a for loop in order to create this list. So let's run through the folder's name, and if the folder exists, apparently it's just double check that everything is okay, then we will append the relevant name into our categories Python list. And let's print it. Great. Let's continue to the next step. Now we would like to create our target folder, and just to remind you, we would like to create a new folder, and inside this folder we will create a train dataset and a validation dataset. So our main target folder will be named dataset for the model, and inside this folder we will create the train and the validate. So now you can see that if this folder, this target folder name, is not exist, we are creating it by using the Python os.makedir function. So basically we are expecting to see this new target name. Here it is, dataset for model. Great. Now we will create a new function, and this function will help us to split the data between the train and the validation and data. We will also create the train and the validation folders, and also we will run the copy process from the source to the target folders, train and validation. The next step, as you can see, is running through each of these subfolders, each of these categories, and getting the name of each of those images, and in each image we are checking whether the size of this image is higher than 0, and if it's higher than 0, then we are adding this file name to our file list. And if it's equals to 0, that means it's not a correct file and we are going to scrape it. So let's run this function. This will be the very initial step, just to double check that we are running through the folders and getting the right names of the images. In this process we will double check the folder names Black C Spark, and we are expecting to see the list of these images. As for now, the last of the arguments will remain empty. We have another error. Let's check it. We have to add another slash. Okay, let's run it. As you can see, these are the list of all the images names inside this Black C Spark subfolder. Okay, let's continue to the next step. You are most welcome to subscribe. More videos will be published soon. So next we are going to split all the files in these folders between train images and validation images. As you saw earlier, 85s, I add another parameter that 85 of the images will be train and 15 will be validate. And before this process we are going to shuffle all the images, so we will get random images for each of the datasets. So the training dataset will be shuffling of all the images, and we are extracting all the images between 0 and the training length, and the validation set will be the rest. That means from the position of the training length until the ends. And then after we created both the dataset, the training dataset and the validation dataset, we will start copy the images, all the images of the training dataset, and the next will be all the images of the validation dataset. Now we are creating the name of the file from the source and the name of the file on the target, and we are using the copy file functions from the sutil Python library in order to copy each of the images from the source to the target. And then we are going to duplicate the process for the validation dataset as well. So basically we are expecting to see two subfolders, training and validation, and in each of the folders we will have 9 subfolders of each of our categories, our 9 types of fish. Now as you can see, we are creating the folder for the train folder and the validation folder. Of course it should be generated only once, but let's create it. It's a crucial process, of course, in order to copy all the images. So we are checking if the folder is already exist, and if not, then we are creating the folder with this name, one for the train and one for the validate. Okay, now we are ready to run our function. We should send the function the relevant arguments. So let's run through our categories, our 9 categories, and let's get the name of the train path. This would be, of course, the destination path, and the next for the validation destination path. Let's add it as well. And once again we are checking if the category folder is not exist on, or let's say under the train folder, we should create it, and the same for the validation target folder. Okay, let's add a print command so we can see what is the source of the image and what is the target of the image. This is just to watch the log during the run. And at last, of course, we have to run our function for each of those categories. So we have to send the source path of the category, the target path for the train, the target path for validation, and the split size, which is 85%. And let's run it. Okay, we have a syntax error. Let's go back to the code. Okay, let's check this error. Okay, as you can see, the path sometimes is with A and sometimes without A, so we have to fix it. Let's take out the A, so it should be PT8, path without the A. So let's run it again. As you can see, now it's running smoothly. For example, in this Black Sea we created about 1,000 images. Okay, this is the second folder. As you can see, now we are in the middle of the copy process. This is the third. As you can see, it's running. I will do a fast forward, so we will jump directly to the end of this copy process. So now we have 5 categories, and this is all the rest. So basically we finished the process, so we can go to the next step, which is building our model. So we will use the MobileNet architecture in order to do this transfer learning process. So let's create a Python code number 2. Let's call it build the model transfer learning.py, and we will start with importing the relevant libraries. From Keras we will import the model object. We will also import from Keras applications the MobileNet version 2 functions. So we will use the MobileNetV2 and the pre-process input function which is relevant to normalize our data and prepare it for our model. We will also use the image library from Keras in order to load the data from our disk and prepare it as well, and several layers like the dense layer, global average pooling, and I believe that should do the job. Let's also load the optimizer, the Adam optimizer. We need it as well for the compile process. So let's copy our train path, which is the target dataset. Let's change the slashes since we are running on Windows environment. Let's duplicate it for the validation dataset. So this is the path for all the images, the training images and the validation images. Now we are ready to load the data from those folders. So we will use the pre-processing function named process input. This is the syntax using the MobileNetV2. So we run in the flow from directory function, and we will send the relevant argument, which is where we stored the train images, the target size, which is not resizing the images to this size, 224 by 224. Let's run it. We have an error. Okay, it should be model. Okay, let's fix it. Okay, as you can see, this is the number of images that we have loaded. Let's do the same for the validation. Change the validation path and run it again. You can see the outcome, how many images for the train and how many images for the validation. As you can see, it's thousands of images, so let's continue. We are creating a base model variable, and that will have the structure of the MobileNet V2 model. We will use include top false in order to chop the last layer, since we are going to replace it with our relevant layer for this fish dataset. So we are going to extract the base model output and a global average pooling layer. Then we are going to add 3 more dense layers with 3 different numbers of filters. The one will be 512 filters. Then we'll add another dense layer of 256 and 128. And the last very important layer is the dense layer with the variable of 9. These 9 represent our 9 classes. So now we have a model, we have the inputs, which is the original input, and as output argument we will add the one that we created just now. So let's print the summary of our configurable model. As you can see, the last layer has 9 classes, and all the rest is the original MobileNet model with our adjustments. So now, before we are going to train this model, we would like to freeze all the model layers and keep unfreeze only the last 5 layers, the one that we just add. So we are going to run a loop through all the layers and define that the trainable is false. Next, we are going to compile it. We are going to use the Adam optimizer. We will define a specific low running rate, since our model is already trained. Of course, the loss will be categorical cross-entropy, since it has several categories. The relevant optimizer that we just have defined in the optimizer variable, and we are going to look for the accuracy of this model as metrics. Okay, let's copy the train data and the validation data. Let's define it, and we are going to run it only through 5 epochs. We're expecting that this low number should do the job, since the model is already trained with more than thousands of classes, the ImageNet. And at last, let's save the model after the train will finish. Okay, we are ready to run it. As you can see, this is the first epoch. Let's see the accuracy. Wow, it's a 0.9. As you can see, the validation accuracy is very, very high. So it should take a few minutes. Let's run it in a fast forward and jump directly to the end. So after the process will end, we will take a new and fresh image of a fish, and let's try to predict what is this fish in the image. Okay, let's test our model. I didn't mention it earlier, but I'm going to leave a link in the description of the video for this code so you can use it as well. So the last Python code will be testthemodel.py. We are loading the MobileNet function, relevant function. We will also import TensorFlow in order to load our model in a TensorFlow format, and let's also use the image from Keras. We will also use NumPy. Okay, and OpenCV as well. Let's get the list of all the categories of the 9 categories. A very simple process. We will run through our folder, the original train folder, and let's get those list names. And print it. Let's run it. Okay, these are the 9 categories names. Next, let's load our saved model. Let's copy the path. And let's use the Keras function load model. And after, let's print the model variable just to double check that it was loaded successfully. No, we have an error. It should be Keras. Let's run it again. Okay, as you can see, the last layer has nine categories, so basically it's our model, it was loaded successfully. So now let's create a function. We will call it classified image. We will send as argument the image, let's say the path for the image, and next we are going to load it and predict it. So as you can see, we are loading the image using the image pillow library list. Then we are resize it to the one that required for the MobileNet, which is 224 by 224. Then we are converting it to a NumPy array. And then, very important, we are adding a new dimension as first the dimension. It should be a batch of images, but since we have only one image, we are adding one dimension before the image structure. Then we are running the prep process, which is relevant to convert the image to the requirements of the model. Now we are ready to run the predictions, and the pred variable, this return value, will have basically 9 different prediction values. So we should get and grab the highest one using the argmax. So category value will have can be between 0 and 9, and it will store the category with the highest value. As I mentioned earlier, that means that this is the predicted fish category. So if, for example, we get the value 0 in category value, that means that this is the first fish, the first category fish was predicted as the one in the image. Then after we have the value, we can extract the name. Categories has the names of all the fish. So we can now run the prediction of a specific image. So this is the image path, and now we are sending it to our function, and we are expecting to see in the result text the name of our category fish. Let's run it. As you can see, the value is 5 and the name is Cbus. So what is 5? 5 is the position between 0 and 9, since we have 9 categories for the fish. 5 is the fifth position, and the name of it is a Cbus. So number 5 got the highest prediction from all the 9 categories. Now we will add another step, that means displaying our fish image, and along with the fish we will also add the text of the name of the category. So we're expecting to see our fish, our test image, with the text Cbus. So we are using the OpenCV, using the ImShow to display the image, and the wait key in order to wait for the keyboard. As you can see, this is the image with the text. I hope you enjoyed this tutorial. You are most welcome to subscribe. Thank you very much.